Thermal energy, conduction, convection, and radiation. Thermal energy refers to energy contained within a system that is responsible for its temperature. James Prescott Joule. The term thermal energy was made up by a scientist named James Prescott Joule, who has a unit of measure also named after him. He noticed that heat was a type of kinetic energy and could be converted from mechanical energy to what is now known as thermal energy. Conduction, convection, and radiation. Heat moves throughout objects in various ways. Three important properties of thermal energy is convection, conduction, and radiation. Does everything really contain heat? The answer is yes. Everything has heat and radiates heat. Even cold things have heat. Anything with molecules has heat. It's just that cold things like this glacier, the molecules that make up the glacier move a lot slower than the molecules in warmer things like a forest. Convection. Convection occurs in liquids and gases. It is the transfer of heat through the movement of particles. As the heated molecules rise, the colder, denser molecules lower, which is called the convection current. An example of convection heat is a two-story house. It is always hotter upstairs than it is downstairs. That is because hot air rises. Here you can see another example of convection where warmer water rises and cooler water descends. Convection method is most known when used in ovens, except in an oven to help the current heat cook the food more evenly. The oven has a fan installed to move the convection current in a more consistent rate. Conduction. The most common form of heat transfer occurs through physical contact called conduction. It is the transfer of heat from a warmer part of an object to the cooler part of the same object. An example of this would be if you had a pot on a stove. It will get hot on the surface that is touching the burner and continue to move upwards the part of the pot. Let's take a closer look at conduction. As the fire heats the metal, the molecules that have direct contact with the flame start to vibrate, and those molecules vibrate, and other molecules start to vibrate, and so forth. The vibration releases heat. Here you can see the molecules as they are very tightly together, and because they are so tightly together, they're able to heat up a lot faster. Looking back at the first image, a spoon leaning up against the pot on the stove, that metal spoon will become hot because the heat will be transferred from the hot pot to the cold spoon. Liquids and gases can conduct heat, but in order for conduction to take place effectively, they must be contained. The reason for this is because the particles are close together but have no definite shape. The same goes for gases as well. The last form of thermal energy is radiation. Radiation is the transfer of energy as waves. Radiation travels through either matter or empty space. In simple terms, radiation is the transfer of heat through indirect contact. Here you can see the radiation coming off the flame of the campfire as the guy warms up his hands. And here is another example of heat radiating off of a space heater, keeping this guy warm. Another good example of radiation is the sun. The sun emits a large amount of thermal energy that we have tried to harness in the form of solar panels. Solar panels capture the radiation of the sun and convert it into energy for alternatives to normal sources of energy. In conclusion, thermal energy is everywhere. Convection, conduction, and radiation are three major forms of thermal energy transfer that has changed almost every industry and every person's daily lives.